Good day, everyone, and I hope that you're doing well wherever you are. Thank you for tuning in. I hope this will be as simple as possible. This week I posted which topic would you want me to start with between microclimates and geomorphology, and most people said geomorphology, and so geomorphology it is, guys. I'm so excited that we are going to start this journey. There'll be a lot of videos that I'm going to release before the June exams. I know some of you guys are writing the March examinations, so if there's any topic that you don't fully understand, please comment on this video below and I will prioritize that topic, okay? I need you guys to understand that we care for each and every member of this family, and we will hear out every concern or reply to any request that you guys have. So for the geomorphology section, the very first video we released, which explains the different types of concepts, explaining the terminology that you have to understand when it comes to geomorphology, like drainage basins, interflows, surface runoff, and infiltration, watershed, river system, so on and so on. That video is in the geomorphology playlist and it's the very first video, and I will leave it in the description box as well, okay? So for anyone who doesn't understand the whole geomorphology section, start watching that video first, okay? So without wasting any time, let's get on to it. So in this video, we'll be breaking down the factors that influence infiltration and surface runoff. We'll also take a look at the types of rivers that we have, the 4 types of rivers that we have, how to identify them, how to differentiate between them. Now, the factors influencing infiltration and surface runoff are critical, guys, because they are also applicable in drainage density, okay? So you can have the write down approximately 8 lines paragraph question on these factors influencing infiltration and surface runoff, and so that's why we have to start with them, because they also form a foundation for many topics to follow, okay? Right, so infiltration, we said that this is when water seeps or soaks into the ground, okay? So if you have water on top of the surface and it flows through the surface, we say that it infiltrates, okay? So it soaks into the ground, okay? And so these water particles will collect into the ground and they will form what we called groundwater, okay? So they will form that reservoir of water that is under the ground, which we call groundwater, okay? And we said that the top layer of groundwater, we said we gave it a name, guys. We said that is the water table, okay? So we call that the water table. That's the top layer of groundwater, the water table, right? As I was saying, guys, we will only say infiltration occurs when water seeps into the ground, okay? Because water does not always do that, okay? So water can actually run on top of the surface, okay? So if it runs on top of the surface without seeping into the ground, okay, just running on top of the surface like that without infiltrating, we say that is runoff. So we call it surface runoff. So this is when water runs on top of the surface instead of seeping through into the ground, okay? So these are directly opposites, okay? If water does not infiltrate, then it will become surface runoff, okay? Now, there are a lot of factors that determine whether we are going to have more surface runoff or more infiltration, okay? So let's get into it before we waste any time. Right, so the first factor that we have that influences infiltration slash surface runoff is soil moisture. So soil moisture, guys, that refers to the amount of water that is already in the soil. So you can have a soil that is saturated. By that we mean that a soil that already has a lot of water in it, right? Compare that to a soil that is unsaturated. So when we speak of unsaturated soil, we're referring to a dry soil, soil that does not have a lot of water particles inside it, does not have a lot of water, or it does not have water at all. Now, the amount of soil moisture you have in your soil will determine whether we are going to have infiltration or we are going to have surface runoff, okay? So let's start with the moist soil. So when you have a moist soil, guys, that means the soil is already wet, right? So it's already filled up with water. And so this whole volume of soil is already filled up with water, such that there's no more space for any more water particles. Now, when it rains, if it's going to rain, where are these water particles going to infiltrate? Because there's no space at all for them to get through or infiltrate into the ground. And so because there's no space available, they become runoff. They become surface runoff. Okay, they do not infiltrate because it is already crowded inside the soil, right? So moist or saturated soil encourages surface runoff. So surface runoff is promoted when you have a saturated soil. Okay, so that's what we're saying. The soil is wet already and cannot accommodate or absorb any more water particles into the soil, and hence surface runoff occurs. So that is when you have a moist or saturated soil. Now, when you have a dry, unsaturated soil, infiltration is indeed promoted because the soil has enough space for these water particles to enter or to be absorbed into it. Okay, because this is dry, the soil absorbs this water or these water particles into the soil, and hence we see infiltration occurring, right? So no surface runoff will occur, but rather infiltration is promoted here. So whenever you have a dry soil, infiltration will occur, okay, because there's more than enough space for water particles to enter through the soil. So as what we're saying, the soil is dry with little or no water particles in this volume, and hence it can allow water to seep in, and hence infiltration occurs. So that is the first factor. Set on to the next one. So the second factor is what we call evaporation rate. Okay, so evaporation, as we know, guys, this is when we convert water, okay, let me rather say we convert liquid into gas or air, right? That is what we call evaporation. Now, the rate refers to the speed of it. How fast does this occur, right? Okay, and so that's why we're saying that evaporation rate is how fast liquid escapes as air. Okay, and how fast really depends on the temperature. Okay, whether it's hot. If it's hot, then that means that there's a high evaporation rate. So many water particles will be turned into air or gas. And if it is cold, because we do not have a lot of energy that will convert that liquid into gas, and hence there's low evaporation rate. So now, how does this affect or influence the amount of evaporation or surface runoff? Now let's think about it. If it is a hot day, there's going to be high evaporation rate, right? So that means that any amount of water that we have there will escape as gas. So it will become gas, right? It is now gas molecules. Okay, so now it has escaped, guys. You once had a liquid there, now it's no longer there, okay, because it escapes. Now, this means that you will not have a lot of water particles infiltrating because they have escaped, or they have transformed or been changed into gas molecules, right? And so we don't see a lot of infiltration that occurs when the evaporation rate is high. So infiltration decreases. It is not promoted, right? So many water particles escape as gas or air molecules, and hence less infiltrate through the soil. Okay, in order for water to infiltrate through the soil, it has to be liquid, guys. If it is not liquid, then it cannot enter through the soil, right? So if it is a cold day, we're saying that there's going to be low evaporation rate, meaning which there's going to be less water particles that escape as gas particles. Okay, so there's going to be less liquid turning into gas or air, right? So if there's less of that, then that means that there's going to be more water as liquid. If there's more water as liquid, then there's promotion of infiltration, and hence infiltration is promoted whenever you have a low evaporation rate. So high evaporation rate does not promote infiltration, low evaporation rate does promote infiltration. And then the third factor that affects infiltration or surface runoff is the gradient of the slope. Okay, so are we talking about a steep slope or a gentle slope? And how do those affect the amount of infiltration or surface runoff we're going to have? Now, we have to take into consideration that water requires a bit of time in order for it to be able to infiltrate. And so if you have a gentle slope, That gives it enough time for it to enter through to the soil instead of sliding down the slope. And so if we're talking about a gentle slope provides the water particles enough time for them to infiltrate, okay, instead of just sliding them off the slope without giving any time to the water particles to infiltrate, right? And so we see more infiltration here when the slope is gentle because the water particles have enough time for them to infiltrate. Infiltration is promoted when the slope is gentle. Contrast to a steep slope. So a steep slope, whenever it's going to rain, when it's raining, these water particles will immediately slide down the slope without infiltrating, okay? And hence they are not given enough time to infiltrate, and so they run down the slope or slide down the slope, and hence a steep slope promotes surface runoff instead of infiltration, okay? The time given to the water particles is not enough for them to be able to infiltrate through the ground. So we're saying that water particles slide down the slope without enough time to infiltrate, and hence runoff is promoted when you have a steep slope. The fourth factor is the nature of precipitation, the nature of rainfall. So that is between a heavy rainfall and a soft rainfall. So a heavy rainfall, whenever it is heavily raining, okay, that means that water particles are pouring in high volume because they are falling at a very fast pace at a short time. This does not give the water enough time to infiltrate. So heavy rainfall reduces the time needed for infiltration, and hence this promotes surface runoff. Remember, water needs time to infiltrate. So if it's going to flood, okay, over a short period of time, this volume of water falling over a short period of time does not give these water particles enough time for them to infiltrate through the ground, and hence we see more surface runoff when it is heavily raining than when you have a soft rain. And so whenever the rain is heavy, surface runoff is promoted. And then whenever you have a soft rainfall, because these water drops fall at a lower speed and they accumulate a smaller volume, and hence they get enough time for them to infiltrate. Okay, so it provides more time for them to infiltrate because they are not falling at the same time at a very fast pace, and hence there's enough time for each water particle to infiltrate through the ground. And so we see the promotion of infiltration occurring whenever you have a soft rainfall. The fifth factor that influences surface runoff and infiltration is vegetation cover, the amount of vegetation you have on your soil. So when you have high vegetation cover, you are actually preventing runoff. Okay, so whenever it's going to rain, these water particles, instead of running off, they are kept in one place by these plants. Okay, instead of running off, because this is dense, these plants keep all these water particles in one place, okay, preventing them from moving around. Okay, so if you keep them in one place, if you keep a volume of water in one place, then it's going to be able to infiltrate through the ground. And so this promotes infiltration. Whenever you have high vegetation cover, you allow more time for the water particles by keeping them in one place for them to infiltrate. Okay, so high vegetation cover prevents runoff, okay, by keeping the water particles or preventing them from moving from one place to another, hence forcing them to stay in one place, and hence allowing more time for them to infiltrate, to enter through the ground. Okay, so this promotes infiltration. We see more infiltration whenever we have high vegetation cover. Compare that to low vegetation cover, okay, or when you have a barren soil, because the water can now move, okay, because there's no vegetation at all, so it can move from one place to another, and hence this promotes runoff because it cannot be held in one place by the vegetation, and so it moves around, and hence we see more runoff instead of absorption or infiltration, right? So low vegetation promotes surface runoff. And then the last factor that influences the amount of infiltration or surface runoff is permeability. and porosity, right? So you can put these in separate points, okay, but they really go hand in hand. So permeability is really the ability of soil to allow water through, and porosity is the ability of the soil to store water. Okay, so usually when you have, let's say for an example, sand has an ability to allow water to go through, okay, because it is made up of particles that are not densely packed. Okay, so particles, it has more, gives more space for these water particles to enter through, right? Okay, there's more space available for water particles to enter, right? So when that makes sand or gravel a permeable soil, right? And so if it's going to allow water through, then that means that water is going to infiltrate. Okay, so therefore, infiltration is promoted whenever you have a permeable or porous soil. Okay, we see the promotion of infiltration. Compare that if you have clay. Okay, clay has low permeability, it has low porosity as well. So it cannot store water, it cannot allow water to pass through, okay, because it is made up of densely stacked particles that do not allow, there's no space for any water particles, or there's very little space for any water particles to pass through, okay, because it is less permeable, then that means it does not promote infiltration. Okay, it's very difficult for this water to go through, but rather it runs on top of the soil, and hence we see more surface runoff being promoted instead of infiltration, right? So the type of soil you have also affects the amount of infiltration or surface runoff you're going to have. Okay, so those are your 5 factors influencing infiltration. Okay, so you have to be able to use them in different scenarios, guys. Okay, so if they are going to ask you to describe how excavation will affect the amount of infiltration on a particular drainage basin, so you would say, well, excavation will result on a steep slope. Okay, so a steep slope will promote more surface runoff because it will slide the water particles down instead of giving them enough time for them to infiltrate. Okay, so you have to use all these different types of factors in different scenarios, guys. Okay, so let's take a look at the different types of rivers that we have. So there's mainly 4 rivers. Okay, it's the permanent river or perennial river, the periodic river, seasonal river or non-perennial river, the episodic river, and the exotic river, right? So start off with the permanent river or perennial river. So you can identify a perennial river in a topographical map with that blue solid line, right? A permanent river is simply a river that flows throughout the year. Okay, so throughout the year, the riverbed is going to be filled with water. Okay, so the channel of the river will always have water, whether it's the dry season, whether it's the wet season, but throughout the year, there's going to be water running on the channel, right? So that's what we mean, guys, right? So how do you identify this river if you are given a cross section? Now you first have to understand that we have 2 lines here. This curve, the first curve that is blue, okay, that represents the wet season. The dotted line represents the dry season, right? And whenever these lines intersect the riverbed, then that means that there is water, okay, in that particular season. And whenever each line is below the riverbed, then that means that in that particular season represented by that line, there was no water, or there is no water in the channel. And so because we know that the permanent river flows throughout the year, then that means during the wet season, this line is going to intersect the riverbed, and during the dry season, okay, the line that represents the dry season is still going to intersect the riverbed as we see here. Okay, it's not below the riverbed, it intersects it, it cuts through it. And so that means that we do have water in the channel even during the dry season. Okay, so we're saying that these water tables intersect the riverbed throughout the year. So the water table during the dry season is of course low because there's less rainfall. That's why this is low, but it still intersects the riverbed because this is a perennial river. There is water, a bit of water running there even during the dry season. Okay, in the wet season, as you can see, the water table is higher, right? Because it rains a lot, and so this fills up the riverbed during the wet season. And so this type of river, you'd find it in areas that experience rain throughout the year, okay? In wet areas, areas that are going to receive a lot of rainfall during the wet season, that are still going to receive rainfall, moderate to low rainfall during the dry season, and hence this river will always be filled no matter the season. And then the second type of river is the periodic river. So we call it the periodic river or non-perennial river or seasonal river. Okay, so it's also called the seasonal river. Now this river can be identified in the topographical map as a dotted line. Okay, so the river with the dotted blue line, that's the non-perennial river. That's the seasonal river. And the river represented by the blue solid line, that is the perennial river. Okay, so we're saying that a periodic river or seasonal river is a river that flows only in the rainy season. Okay, so if the rainy season in that particular area is from June to July or from June to August, then that means that this river will only fill or will only be filled with water during those months. And then during December, it will be dry, right? So that's what we mean. It has only water flowing in it during the rainy season. Okay, and so as you can see, depicted by these water tables, so in the wet season, as you can see, the water table does intersect the riverbed. Okay, so that means there is water running there during the wet season. But in the dry season, the water table goes below the riverbed. So if it is below the riverbed, then that means that there's no water in the river channel. Okay, so during the dry season, you have no water flowing in the channel, right? And so you find these types of rivers in areas that receive seasonal rainfall. Okay, so once you have a non-perennial river in your topographic map, then that means that that area receives seasonal rainfall. Okay, so utilize that, guys, right? Utilize the information that you see in order to make informed decisions. Okay, now the third type of river we have is the episodic river. These two types of rivers, the episodic river along with the exotic river, their water tables do not intersect their riverbeds in both seasons, during the wet and the dry season, right? So for the episodic river, okay, episode, guys, I'm sure you guys do watch soapies and so on and so on, but you'd find out you have that particular episode in which there is the climax of that particular show, and you would only find it during a particular time. Okay, and then a long time passes by, and then another climax occurs, so on and so on. So episodic rivers really resemble that because these are rivers that only flow for a short period of time after a heavy rainfall. Okay, so that means there has to be a heavy rainfall. It doesn't matter whether it is the dry season or the wet season. The only time that this river will be filled with water is only after a heavy rainfall, right? So that is what we call an episodic river. It's found in dry areas, and dry areas usually do not receive a lot of rainfall. But when they do, these rivers flow. Okay, so that's what we call episodic rivers. Okay, so let's talk about the water table. The water table, as I said, guys, is below the riverbed. It does not intersect the riverbed in both seasons, in both the rainy and the dry season. It's always below the river bed. This river cannot sustain itself because there's not sufficient water for its water table to rise or intersect the riverbed. And then an exotic river is a river that flows into dry regions, having originated from wet regions. So it really comes from a wet area or an area that rains a lot, but it flows through dry regions. So it's really not indicative of the area that it flows through. So it will originate from an area, let's say this is area A, okay, This area is a wet area. Okay, it rains a lot. Okay, it receives a lot of rainfall. Because it receives a lot of rainfall, its catchment areas will supply a lot of water to the river. And so the river now, when it flows to other areas, the river can flow through many different types of areas. It can flow through these dry areas. Okay, so if you are visiting here in this dry area, you'd be surprised that we actually have a river. Well, this does not originate here. It actually originates from a wet area. And so we then call it an exotic river. It flows through dry areas originating from wet areas. Okay? So that's what an exotic river is. Its area, the area it flows through is dry, right? It does not receive rainfall frequently, and hence these water tables will always be below the riverbed. They do not intersect the riverbed in both the wet season and also the dry season. Okay, so that means that it's much difficult to tell the difference between episodic river and exotic river when you are just given these cross sections, because they look exactly the same. Right, so that's how you differentiate between these four types of rivers, guys. And it's very important that you note what is happening there. You note the differences between them. You have to be able to differentiate between them. You have to be able to identify them. Read the statement that you are given, and that will enable you to identify them, okay, with any other resource provided. Right, so that's it for today's episode. Please mention any topic, any geomorphology topic that you would want me to prioritize or start with, or that will make up the next episode, so that we start with it. We don't have to go in order, guys. I go by request, okay? So if you have any questions, send them via the comments. You can send them through my email. And please like, share, and subscribe. We love you all.